question is, are salt solutions acidic? Are they basic? Well, let's see. Let's go ahead and look at sodium chloride. You have a sodium chloride salt, which is a solid. You have a crystal lattice with the ions together. When you dissolve that in water, the water separates the sodium plus and the Cl minus. The sodium plus is now exposed to water, okay? And the Cl minus is exposed to water as well. Do you see any H plus that could make it acidic, or do you see any OH minus that could make it basic? Well, currently you don't, but the Na plus can potentially bond with the OH minus of water and make NaOH. Now let's think about this. Will this happen? Well, no, it wouldn't, because you know that NaOH is a strong base. You memorize the strong base. Any alkali metal hydroxide is a strong base, which means they don't want to be together. They want to be apart, which means this cannot happen. This attraction with the Na plus with the OH minus is not going to happen. Okay, now let's see Cl minus. Will Cl minus attract the H plus and leave the OH minus behind and make HCl? Let's think about that. Is HCl a strong acid? Yes, it is. You memorize the strong acids. Therefore, they don't want to be together. They want to be apart. Therefore, this extraction of the Cl minus with the H is not going to happen. NaCl in water is neither acidic nor basic. It will be neutral. Okay? Let's look at a different salt. This salt is NaF. Remember, the definition of a salt is any ionic compound. Anything with an ion and another ion, a metal and a nonmetal. NaF is also a salt, a metal and a nonmetal. When NaF dissolves in water, and you know it's soluble because potassium, sodium, ammonium salts, wherever it can be, they can always be dependent on solubility. So Na plus will dissolve, and you'll make Na plus and F minus. Okay, we already know that Na plus is not going to attract OH minus, so that can happen. But will F minus attract H plus and make HF? Okay, is HF a strong acid? Nope, it is a weak acid. Therefore, they want to be together. They want to be together. A weak acid means the HF does not want to get rid of the H. That means the F is very attracted to the H. They want to be together, which means when you put NaF in water, the F minus, first of all, the NaF will dissociate into Na plus and F minus. The F minus will hydrolyze or react with water, so you're going to add H2O. And what it will do is it will extract the H from the H2O. So the H will go this way, and you'll make HF floating around in the water, and you'll also make what's left over, OH minus in water. And you're going to cause the F minus will cause the solution to be basic. Okay, so if you add NaF with water to water, the Na plus won't do anything, but the F minus will act as a base, taking in the H plus, and remember bases accept H pluses this way. So F minus here is a base, taking in the H plus and becoming HF, and now you have a basic solution because OH minus is produced. Okay? So, as such, they can react with water in a hydrolysis. Hydrolysis means reacting with water to form either OH minus right? And it can also hydrolyze to make H plus. In this case, that didn't happen. It just made OH minus. Okay, so here the F minus reacted with the water to make the HF and the OH minus. And this made your solution basic. Okay, so the conjugate pairs, this is the conjugate pairs, HF minus and H. This is the base, and this is the conjugate acid. Okay. What you have here, F minus, is an anion. Anion are negative ions, like F has a negative ion. An anion has the ability to react with water, and its ability to react with water depends on the strength of the acid. Here, the conjugate acid is HF. The acid has to be a weak acid, which means it really, really wants to keep the H. It's a weak acid, which means the F minus wants to keep the H plus, so the H plus won't come off, and so it's a weak acid. Okay. So if the F minus really wants the acid, then it is a stronger conjugate base than it is an acid. So it's a stronger base than it is an acid. Okay, so if you have a strong conjugate acid, this one is a conjugate acid. If conjugate acid is strong, HCl, that means the H wants to come off and it'll burn you. Its conjugate base, the Cl minus, doesn't want the H plus. Its conjugate base, Cl minus, will be, if you have a conjugate acid is strong, its conjugate base will be weak. So it won't take H from water. So Cl minus does not want the H. Does not want H plus from the water. So when you put these together in water, nothing happens. Just like when we look over here when I drop NaCl in water, it's still neutral. Okay? Now if you have a weak conjugate acid, like HF is weak right here, because it's not one of the top 7 that you memorized. If the conjugate acid is weak, like this acid is vinegar, it's a weak acid, its conjugate base will be strong. So what it will do is it will take the H plus from the water. So CH3COO plus H2O, it'll extract that H plus from the water, becoming CH3COOH plus OH minus. It will be left over. So this will cause your solution to be basic. The salt will increase the pH, so it's basic. Okay. If you have an amphiprotic substance like HSO3, amphiprotic means it can be either an acid and a base. HSO3 can act as an acid and a base. Okay, I can tell because HSO3 minus, if you take in another H plus, it becomes H2SO3. And this H can be removed to become SO3 minus 2. So it can either take or give, okay? So let's go ahead and look at it both ways. Acid is HSO3 minus. When it's acting as if this is acting as an acid, then you're going to make H plus and SO3 minus 2. And that has its Ka. All right? Now, HSO3 minus acting as a base, that means it'll take the H this way from the water. So you'll have H2SO3 plus OH minus. Okay, so this has a Ka of the HSO3 minus when acting as an acid has a Ka of 6.4 E negative 8. The way that I got that from this table, the appendix D, HSO3 minus, and it's the second H. This is the first one, H2SO. This is the Ka of H2SO3, giving away its H plus, and this is the Ka of HSO3 minus, the second H coming off. Okay, so you want to use this number, 6.4 E negative 8. That's the Ka of that one. Okay, so this has a Ka of that. To figure out whether if it will be an acid or a base, you have to say which is bigger. Is Ka of HSO3 minus bigger than the Kb of HSO3 minus? Whichever is bigger will win. So because HSO3 minus can be an acid and a base, it'll have a Ka and a Kb. Okay, so to find the Kb, you have to look that up in the chart, and when you look it up in the chart, these are all Kas. The Kb's is a very small chart right here, and they all have ammonia or nitrogen in them. So it's not in there. The reason this is a small chart is because you can get the Kb from the Ka using Kw here. So you're looking for HSO3. Are you going to use the first one, Ka1, to get the Kb, or Ka2? Okay, that's a little tricky. This is very, very tricky. So let's go ahead and look at the equation. Do you see its conjugate acid? Its conjugate acid is H2SO3. That means you have to use Ka1. Okay, so since Ka times Kb equals Kw, Kb is equal to Kw divided by Ka. Okay, Kw is equal to 1e to the negative 14. The Ka is going to be, since H2SO3 is the conjugate acid, you have to use this one, 1.7 E negative 2, because this is the conjugate acid of HSO3 minus, and these are all Kas, so 1.7 E negative 2. Divided by 1.7 E negative 2 is equal to 5.9 E negative 13. Okay, so you have two numbers. Okay, let me tell you what they mean. This is the Ka of HSO3 minus, because HSO3 can act as an acid. This is the Kb of HSO3 minus, because HSO3 minus can act as a base. Which is bigger? This one. So if you put HSO3 minus in a beaker, it will be acidic because Ka is bigger. Okay, let's just summarize this. It's a lot of information. So salt solutions can be acidic or basic. It depends on the ions. Okay, so if it combines with the water to make NaOH, a strong base, nothing will happen. Cl minus plus H, HCl, a strong acid, nothing will happen. Okay, because that won't work. It won't hydrolyze with water. But if it can hydrolyze with water, like HF, then it will give you OH minus, then it will be basic. Okay, so that's hydrolysis, reacting with water. And you can have anions are negative, they can take the H plus from the water. Okay, and you also have amphiprotic substance that can either be an acid or a base. and you just have to figure out which one has a higher Ka or Kb.